Very good evening, Lakshmi. How are you? Let's wait for 1 minute more, then we'll start with the class, okay? Okay, then let's start with the class then. Very good evening, Bani. Okay, so let's continue. As you already know, this is a third session of the same chapter, alcohol, phenol, and ether there. So in the previous class, let me give you a quick brief which topic we already covered, right? So in the previous class, we just discussed about that how to prepare the alcohol from the carbonyl compound, okay? So there we discuss about if let's suppose we are having aldehyde. So basically, we're going to follow the three method. That is, you can undergo acidic hydrolysis there, hydrogenation, I'm sorry, or like platinum and platinum can be there. Or the second method that you can use NaBH4 as well, or even you can use lithium aluminum hydride there. Okay, so same you can go with the ketone, and yes, we just discuss about this portion there. Now in today's class, the topic of discussion is what, that how to prepare the simple alcohol from the Grignard reagent. Okay, so you can say from Grignard reagent is the key point. Okay. Now, just write in a bracket. It's really, really important. In this case, we are getting one extra carbon bonded to the alcohol there. Okay. For example, if let's suppose you are starting with some R, COH, let's say. Okay. So in this case, if let's suppose I'm using some RMZX there. Okay, wait. Let me just write it here. Okay, so what is really happening there? For example, if let's suppose I'm starting with this R COH group there and a Grignard reagent, let's suppose this is some R MZX. Okay, it's a Grignard reagent. And then what is going to happen there? That we're getting R COH and this is a R dash. Like if you have to count the number, like in this reaction, that only R and C is there. But now along with R and C, the extra R have to be there. So if you want to increase the number of carbon in alcohol, so we are going to follow this reaction, Grignard reagent one. Okay, so this is how that we are using a Grignard reagent simply. Okay then. Now Let's discuss about the like how to deal with the mechanism there. So let's just start with the very first topic, grignard reagent. How it is typically look like. This is how the reaction look like. Simply you will be having this reaction. This is as like what is really happening. Let me just explain actually how the mechanism followed here. Okay, wait. Okay, so in this case, how about the mechanism there? If you have to observe this simply, look at this. This carbon is a partially positively charged, right? And this oxygen is partially negative charged. Okay, simple sorted. Why? Because the carbon is positive and the oxygen is negative there. Like similar, if let's suppose I'm considering the RMZX there, so you know very well that magnesium is a metal simply, right? So the metal got a positive charge and R got a negative charge. Like this is simply how the charge arrangement is there. Okay, so it's obvious like how but the reaction is going to take place. So let's discuss about the mechanism for this Grignard reagent one reaction there. So let's just start with the mechanism. Okay, yes, for this reaction, mechanism is going to be the very much important part that how to follow the mechanism. So you will be having some R, CO. Okay, this is aldehyde. I will tell you about the ketone as well. Just wait for a while. So now you're using some R, M, ZX. As we discussed, there's a negative charge, there is a positive charge, and here that oxygen got a negative charge and this carbon got a positive charge. Okay, so just try to understand really actually what is going to happen in this case, that this is a R and this is a C and this is a hydrogen. So what is the negative part? This is a negative part, right? And this is a positive part. So negative positive is going to combine, right? So simple sorted that in this case, if you're observing that R part is going to connect with this R des. Okay, like this. And actually how the mechanism is going to take place, this R negative simply attack here and this bond simply open up like that. Okay, so you can say this oxygen got a negative charge here, and since there's a negative charge, magnesium be like, wait, why not I can combine because I'm a positively charged species. So this is a step number one. Simple, that the R is going to attack on a carbonyl bond, CO bond. Okay, now next step is going to be the hydrolysis. So like we used to write it's a hydrolysis, or simply you can write that is a H3O positive, or sometime we can be like H positive and water is there. All three things are same. Hydrolysis, H3O positive, H positive or water is there. Okay, so now let's see actually what is now really going to happen in this case. So you know water is what? Water is H positively and OH ion there. So what is really happening? This magnesium is combined with the OH part, and if we are observing this here, so this OH is combined with this oxygen there. Okay, so this is how the reaction is going on. So let's see that actually what is going to happen now. So in this case R, this CO, O is combined with the H, and this RDS will remain same in hydrogen, and this magnesium is combined with definitely with the OH there. So it's become MgOH and X is there. So this is how the mechanism is there. It's very simple mechanism. Just try to understand the mechanism, like actually how the reaction proceed. Now the point to be noted here, what is the point we are going to note from here? Look at this, like which kind of alcohol we are entering with this time now? That is a secondary alcohol. If you remember in the previous class we discussed about that if you are having a aldehyde, so we are getting a primary alcohol, and if you are having a ketone we are end up with this the secondary alcohol there. But this is the only case where although we are having aldehyde, but still we are getting that as a secondary alcohol as a product. Okay, so it's really very much important. Okay, you can generalize the reaction even as well. For example, let's just take a general example. Okay, for the example, obviously we are not going to follow the mechanism. Now we are simply going to apply the trick simply. Okay, so how about the case again, that let's suppose you are having some CH3 and this is some COH is there. And in this case, if let's suppose I'm using this is a CH3 MZX there. So what we are getting now, that we are getting this is a CH3. Okay, so simple that this OMG6 is connected here and the CH3 group is connected here and hydrogen. In the next step we are going to follow the hydrolysis. So what we are end up basically that we are getting, it is a CH3 and OH and hydrogen and CH3. So if you have to observe something, like here we are starting with 1 and 2 carbon, but in the final product we are getting 1, 2 and 3 carbon. 1 carbon extra increases there. And again, it's a secondary alcohol, like how about the name of the alcohol there? So it's become 2 prop propanol, okay? 2 propanol, or you can write that propane 2 all same, okay? So this is how the name for this compound. I hope this part is clear for you. Now let's continue with the ketone. What if I'm having a ketone? Then how to proceed further, okay? So let's just discuss about the ketone part as well. So let's just talk about the ketone. How about the ketone there? If let's suppose you are having some R, COR is there. Okay, let's say this is R dash, and then let's see this is R double dash magnesium oxide. Now the mechanism will remain same, like ditto, like we just discussed same mechanism there. So this R, partially negative, this is partially positive, and this negative simply attack here, this bond open up, and what we are getting then, we simply got like there's a O negative, it is combined with MgX there, and this is R dash and this is R double dash, okay? Yeah, you can change the position. It's not like that R is going to be there. It can be changed, like it's a R dash, it's a R double dash. And then again we are going to follow the hydrolysis. Ditto, the same mechanism is there. If let's suppose you are having a water, so how the water going to add? This is H positive, this is simply adding here with this, and the second part is simply added with this, okay? So this is how we are getting, and what will be the final product in this case? That R CO, and R is already there. Oh, I'm sorry, it is going to be the OH. Okay, it's R dash and it's R only. Now what is it? If you to observe, this is what, it's a tertiary alcohol. So this time the complete scenario changes. Ketone, with the ketone we're getting tertiary alcohol, and with the aldehyde we're getting a prime secondary alcohol, okay? So as this is all for the case. Any problem with the Grignard reagent? According to me, this is one of the easy mechanism out of all the mechanism right now. Yes, please, any problem still you are having, then please consult with me. Okay, I guess no. So let's solve a question, okay? Then please answer this question, okay? This is a question for you. Question, what is it? It's a cyclohexanon, okay? In this, okay. Yes, please, what we are getting this, okay? So I will give you some option. Option number one, option number B, option number C. I have to write the option C here, okay? This is the option C, or option D. Yes, please, what is the correct answer here? Very good evening, Apyan. I will repeat. Hasio. Okay, Lakshmi. I already know. Okay, then, very good everyone. Option C is going to be the correct. It's really easy, right? So what is happening again? This is a partial negative, it's a partial positive charge there. And like how it is going to attack here? So this is simply how it is going to attack. This negative part connected here, this bond up and up, and then like OH and the CH2 is the correct answer, option number C. Now you will be having a doubt with the hydrolysis. Let me just explain how to proceed. You are going to get, this is some aldehyde, let's say, okay? And let's just quickly add, this is a HZM, okay, like this. Then negative one combined with magnesium X, and this is combined with the CH3. Okay, now how about the hydrolysis? That You know very well, we can't directly use the water. Okay, along with the water, at least we have to add little bit amount of acid. Yes, we are going to add like diluted acid. It's always written. Okay, so it means in the water you are having some H positive ion as well, right? So water try to trap that H positive ion from here. Okay, like this H positive ion, and then it become hydronium ion simply. So you can write hydronium ion, or you can write like H positive added into the water. Both are the same thing. The main agenda is what, that is water is water being hydrolyzed here. Okay, so it means that in this case this is my H positive and this is OH negative ion. Okay, so actually how really the mechanism is going to take place, let me just explain this. Okay, like this one has a lone pair, and like this is H positive ion, so this lone pair attack on H positive ion. Okay, so just because of this bond is going to break. And then this is a R, and a OH group simply connected here, hydrogen and this CH3, and this magnesium now have a positive charge. So magnesium combined with the OH ion. So this is how the hydrolysis take place. But be noted, like as we know, magnesium has a partial positive charge and oxygen has a partial negative charge. So just simply added H positive and OH ion. Okay, Hasio. So this is how you can undergo the hydrolysis part. Okay, I hope it's okay now. Okay, welcome, not an issue. So let's just continue now. Okay, this is all for the reaction. Okay, what if, okay, what if you will be having acid? For example, if let's suppose I'm having, this is the acid there, RCOH is there. Okay, this is some acid. Now same, if let's suppose you are having some RMZX there, okay, RMZX like this. And in this case, same like this one has a partial negative charge and a partial positive charge. This is simply attack again here. Okay, this is how the thing look like. So you will be having R, and this is the O negative charge. It is combined with MZX. Okay, and this is some OH already connected, and this R simply connected here. Let me just change this R like this green R. Okay, so let's just highlight this is the extra R which we are adding from the Mg part. Okay, now in the second step, that what is really happening in this case, that this is a O negative. Okay, oxygen has a lone pair. So in this case, what is extra point here, that this is going to trap more H positive. Like if let's suppose you can go up with the hydrolysis part here, so the H positive now there, and this OH attack on the H positive ion. Okay, so what we are getting in this case, we're getting R O MZX. Okay, and this is R, and this is how the water molecule formed. And this negative charge has a like negative, so this is how this pushing, and this is how it's pulling. Okay, so what is happening simply, that water molecule evolved out, and again we are getting MZX. Okay, this is how simply we are getting the thing here. Now the next step is what, that again you are end up with the RCOR is there. Okay, so if you are having like acid, so what is the different point here, that again one more time you can undergo the hydrolysis. So be noted, first of all grignard reagent is going to add in acid, and then again hydrolysis, then we are getting ketone, and then you can proceed further. So, like what I want to highlight to you, for example, if let's suppose you already have a ketone like this, okay, and if I'm adding CH3 and MZX there, so what we are getting this is a O and a R, and a CH3 group is connected just because of the Grignard reason. But on the other hand, if let's suppose I'm having some acid, it is not only acid. Let's suppose you can, if let's suppose you will be having ester, so the same procedure we are going to follow. Okay, in both the cases you have to use two time, like 2 mole of the CH3 and MZX there. Why? Because it followed two time mechanism. So what will be the final answer? We are getting that is a OH, and then CH3 CH2, and a CH3 CH2 have to be connected two time. Means every time the final answer have to be this. Okay, preparation for, we are discussing, oh you are asking about the preparation for printer, why I just forget about that. Okay, I will send you in a group. Okay, Abhishek, the preparation part, I'm sorry I forgot about that. Okay, Okay, then this is all for the case. This is all for the preparation then. Now let's move further, okay? Now let's see the second preparation. Okay, this part done. Let me just solve the slide. This part done. This part is already done. Now this is a question for you. Answer this question. And it's a PYQ. Z 2007, okay? Yes, please answer this question. How to follow the steps? Yeah, you can use anhydride as well, Abhishek. Okay, everything you can use anhydride, acyl chloride, even that acid, or even you can use ester. Every carbonyl compound you can use for this mechanism because they are very good living group. Yes, please answer this question, please. I guess it's not difficult for anhydride. Okay, wait. I will explain the anhydride part as well. Okay, wait. Till then, you can solve the question, please. Okay. Let's suppose you are having this again. This is anhydride, right? And again, that if you have to add that R, MgX, okay, if you are using this, so simply that again, this MgX part connected here, and this CH3 group connected here, and this is O, CO, and R there. Again, just because of the hydrolysis, what is going to happen? This is like combine with hydrogen. This is a very good living group now. And again, this lone pair here, what we are getting? We are getting R, double bond O, and a CH3. And this side you will be having acid. This is already acid formation take place. Like this is a COR, NOH. Then further, if you to add the same like R MgX there, let's suppose you're using CH3 MgX. So what we're getting again, that R COH is there, and it is a CH3 and CH3. Okay, this is the final product, and this is anhydride. Okay, Abhishek, is this okay now? Okay, okay, answer. Wait, I will check like with the answer question slide. Okay, take your time and then answer the question. Very good evening. Okay, what will be the A? Like actually what is going to happen in A? Okay, so like this class consists of all the topic now. Some part from the haloalkane and halurene chapter, right? So see, how about everyone? Please, everyone respond. What will be the correct answer for this question? Okay, Hasio. Alcohol. So, like C and D both are alcohol then. Okay, Mini. Yeah, Abhishek, you already answered earlier actually. Okay, so it means like maximum voting for the option number D. Let's just check. Is it correct or not? So, okay. So in this case, what we are having basically that this is a CH3, okay, and it is a CH2 and OH is there. Let me just check, am I right? Yeah. And then we are having a P plus I2. It's nothing that it helps us just to form the iodine there, okay? So it means in this case, what is the extra point you will be having? This is some CH3, this is some CH2, and then iodine simply connected here. This is a case number one. And now it means this is our typical A there. Let's just back again. Now you have to add some Mz, like Grignard reagent we want to form, right? So as soon as you have to add Mz, as we know, if you are using Mz in a ether or dry ether, make sure, okay? And then, so basically what we are getting then, that simply Grignard reagent form. So this is a CH2, CH3, and it's a Mz and iodine there. Okay, and the next step we are using formaldehyde. This is a formaldehyde, right? So what is happening there? That this is a partial negative, this is a partial positive. So like how about the attack there? This negative charge simply attack here. This is both this bond open up, and then you will be having CH3, CH2, and this is a CO. Okay, here MZX part is connected or I part is connected, and hydrogen, and then further the next step is the hydrolysis. I guess it's B, it's C. Okay, this is C. Then where's the B? A B. Okay, this is the SP. BC. Okay, and then you have to hydrolysis this. Then what we're getting simply there, that it's a CH3, then CH2, and then OH. So what is it simply? What is it simply there? That is its propanol. Okay, N prop. If you have to observe that N prop, because it's a straight line simply N propanol. So this is a correct answer. Let's just check. Yeah, option D is the correct here. Okay, N-propyl alcohol you can say. So very good, Hasyu and Mini and Abhishek, you're right. Okay, not an issue like me. Okay, if you don't know, okay, if you don't know, of course we are going to discuss, right? That's why we're taking the piece the phosphorus, piece the phosphorus, Hasyu. Okay, phosphorus, nothing. Okay, Hasyu, is this point clear for you? Okay, I hope it's clear. Now let's move further. Okay, previous slide. Wait, the solution one, right? This is an prop. Let me just write it fairly. So it is a CH3, CH2, CH2, and OH. So it's a N propanol. Oh, I missed one P. Okay, is this okay now, Diksha? Are you done? Disika. I'm sorry. Okay, so let's continue further. Now let's see the next point there. This is all for the question. Next question, please answer this question. So this question you can say the brief of all the classes till now. Like, okay, I'm not explaining. Just answer this first, then I will explain the solution. If you know, you can tell me the name of the reaction as well. Like one is given HgOC and NaBH4, and then two is given NaOET and ETBr, then fourth is BH3 and H2OH. We already discussed all the reaction, right? So yes, please answer the question. 1 minute more, you, not more than that. You can apply the elimination method like P and Q. There's a tie for A, C, and C, B, D. D. Okay, Diksha. Okay, Lakshmi. Okay, Abhishek. Okay, Niharika. That's it. Okay, let's discuss how to approach the question. Okay. Okay, Abhiyan. So let's see. Actually, it's a really interesting question. Okay. So first of all, in the option number P, okay, in P, actually what is happening? Okay, so let's discuss about that in the option number P, like what is really happening or what is the name of this reaction. Okay, so in the first case, you will be having this tertiary and it is a chloride, and then we are getting it's a double bond like this. Okay, so can you just tell me like what is it? Options are like elimination reaction, substitution reaction. What is really it is? What is it? Elimination. And if it is elimination, then what we are going to do? I guess we are going to select a very strong base. Remember, I already told you this thing there that if you will be having a C2H5 and some alcohol is there, and if there is some sodium present or some potassium present, so it's going to be a very strong base. So we're requiring a kind of base, right? So let's just back again and now observe this. Like if you can go with like option 1 and option 4 apart, okay, leave that. But look at this, in this case, NaOH3. Okay, in this case, we're having NaOH3 there. So look at this. Obviously, that is P is going to end up with the option number 2 because it's a strong base. Okay, it's a hint as well. Look at this. This is already ONA. Let me just explain this Q part as well. Then you will get actually what I want to explain to you. That in this case, this is already ONA, right? ONA. And from this, we are basically getting that OCH3. If you, I guess, did you notice something? From there to there, the only difference is what? This only. O is already connected here. So like if you are going, Q is going to connect with the option number 2. It's wrong. It's absolutely wrong there. Okay, because we want only ET there, and this is the only option where we are having ET left because bromine is going to combine with Na. Okay, so see this, like P go with the option 2, so P2, P2, this in this absolutely wrong option. If you are doing a problem between like P and Q option, it means like still your reaction mechanism is not very good, right? Okay, Hazio, you have to use alcohol, okay? Alcohol. Alcoholic, like what I saw, wait, alcoholic KH. Okay? Question Q is, where's the question Q? Yeah, you're right. You're right. It's a Williamson synthesis there, okay? So in the upcoming classes, we are going to discuss about that as well, okay, Hazio? But yeah, you are right, basically. Or I guess we already covered in a reaction mechanism, I guess, already. I don't know, but maybe. Okay, so P you go with the Q there. Now let's just check with the Q option. So in Q, like this is the simple case. Let me just explain the Q part to you. So like you will be having this is a ETBR. Okay, and can you just tell me the mechanism as well? Like should I to go with the SN2 mechanism or SN1 mechanism? Options are SN1 or SN2. Okay, Hasio. But isn't it like tertiary OHNA something there? Just do this, right? Come on, very silly mistake. See, this is my nucleophile. Who's the real reagent here? This is the real reagent. Why not I can write what is it? Primary halide simply. It's a CH3, it is a CH2, and it's a B bromide there. Okay. So open your mind and be noted. Reaction mechanism is not that much easy. So actually, this is my reagent. This is my primary alkyl halide. So it's clearly observing it's alkyl halide, and this O negative simply participated, and this is going to leave. So it's obviously the SN2 mechanism. It's not SN1 mechanism. Okay. Yeah. It's not cheating. Are you getting my point? It's SN2 mechanism. It's not SN1 mechanism. Okay? So I hope it's clear, right? So let's just back again. So it's a SN2 mechanism. Let me just erase this now. So like Q can go with the 3 or 3. So 3 and 3. So still we are not able to identify like option A is the correct or option C is the correct here. Okay. Now let's start with their mechanisms. So in option number R, if you have to observe, like what is it? Is it Marconic addition or it's anti-Marconic addition? Yes, please answer the question. In the option number like R, is it Marconic addition or is it anti-Marconic addition? If you know Marconic and anti-Marconic here, then it is very easy to solve. Like you can go with the oxymercuration or demercuration or the hydroboration reaction. Marconic addition, right? So in which case we are going to follow the Marconic addition then? Option number one or like option number four? Recall. Where? Yeah, it's a Marconic addition, but in which reaction we are going to follow the Marconic addition? First. Oxymercuration, demercuration. I already told you so many times oxymercuration, demercuration, you are going to follow the Marconic addition, and in hydroboration, anti-Marconic syn addition. Remember? Yes, option one is the correct here. So simply that if you have to go with the R there, so R is going to be combined with 1 there. So R1 and sorted, it's the correct answer here. And how about the R there? Like in this case, see, if you're not observing the small point, okay, it's difficult to solve the organic chemistry question. See, in the S, it's S already explaining the point here, that in S what we are having really there, that wait, okay, you are having a, I'm sorry, I have to change the color. Okay, this is simply, it's a 5 member ring, right? And in the option how we are mentioned there, that we are mentioned be like that the OH as the desk position if you're observing, and this is how it's look like. So it's understood totally that my H is actually at the wedge position, sorry, desk position. And what is it? It's a syn addition. This is only possible in only one case, that is hydroboration reaction. So let's just back here. So this is a very good question. I hope now every topic till now is clear, pretty much clear for everyone, right? So see this option number S there, like uh observe this OH which dash position here, and hence option S is the correct here, like 4 4. So that's it, this is all for the question. Any problem still you are having, let me know. Okay, so I guess it's enough. But anyone still you are having problem, so it means not even a single one able to answer the question properly. Okay, so please, it's a request, organic chemistry require revision, so revise the thing properly. Okay, I will repeat, of course. Okay, listen, that, okay, is this point clear? First of all, in the option number A, okay, P and Q, let me just explain between P and Q there. Okay, so in a option number P, wait, I am erasing all the thing now. Listen. That is an option number P. We are having, this is a Cl. Okay, this is a simple Cl. Okay, and what we are given, you are given with this. So what is this, Dashika? That this is chlorine, this is my alpha, and this is my beta, and this is some hydrogen have to be there. So basically what is really happening here, you will be having some base. Okay, base simply attack here, this hydrogen be like this, and this chlorine have to be leave. So it's nothing, we are given with elimination reaction. Okay, so elimination there. Now the question be like that in elimination reaction, what is the reagent we are going to use? So I already told you, first of all, that alcohol is behaving like a acid as well as a base. Okay, it is behaving like acid. Why? Because in this case, if you have to observe C2H5, O negative and H positive, so it's H positive donor. But sometime it's also behaving like a base. When it is behaving like a base, that if you are having alcoholic QH, that let's suppose you will be having alcoholic QH, it means the same thing I'm using in alcohol. So this is my C2H5, OH is there. As we discussed, it's a base, sorry, acid. Okay, just for this part only. Okay, I'm going to write KOH be like this. Okay, I know it's wrong, but try to understand. Okay, this is negative. So, like what is really happening there? This is OH. OH is combined with this hydrogen like this. Okay, it means water molecule is going to remove, and we what we are getting C2. H5, O negative and K positive. Okay, that's it. This is a strong base. Whenever you are observing any alcohol with a K positive ion, or it's simply written alcoholic acid, so be noted, it's totally highlight us like you have to select this is a strong base. Okay, strong base, the condition number one, it's an elimination reaction, we're going to select the base. Now observe all the option there. Out of all the option, only observing this is the case where you are having NaOET there. Okay, so sorted, P go with the 2 there, so P2, P2, so this and this automatically remove. Now in Q option, what you're observing, that it's a kind of substitution reaction. Okay, let me just explain the Q part as well. Like how about the Q there? So in the Q option, what we're doing? Okay, that this is, I'm sorry. Okay, this is O negative and Na, and then you will be having ETBr. Okay, ETBr. Okay, so see this. This is O negative, attack here, and this bromine is going to leave. Okay, so what we are getting simply that this ET part connected here with O like this, and this NABR released there. What is it? It's a substitution reaction. Okay, it's a substitution reaction. Why? Because if you were to observe, OH is replaced by ET there, so it's a substitution reaction simply. Okay, so only the option number like second, if you are observing in this question, let me just back again that, oh sorry, only in this case if you were to observe this ET and EBR, so Q go with the 3. Any issue with this point? First of all, Dishika, that why the like 2 and 3 is the answer for P and Q. Okay. No, as you okay. As I already told you, like organic chemistry is what? First you have to remember thing and then understand the thing. Okay, organic chemistry is not that much easy. Okay, but once you will like know the thing, okay, it's very easy. Okay, this is a reaction is given, and then be like, okay, mind this is going to remain, and trust me, it's very easy to solve the question. Okay, so just practice all the thing. Got it? Okay, let's discuss about RNS part only. Okay, so let's just discuss about RNS part. So, yeah. So it is what is happening in RNS part here. Why it's not? Okay. So in option number R, first of all, that this is a simple, it's a five-member ring, it's a double bond, and like this. Okay. And what we are adding simply, that we are adding some HBr. Okay. No, 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 water, I'm sorry. That water, addition of water, simply. Okay, so in this case, we will be having two choices. Like you are having H positive and this simply that OH ion there. So condition number one, that maybe the OH group connected here, like this. Condition number one. Or the condition number two, that maybe the OH group connected here. So I have the condition number two, that this O is connected here, like this. Two condition we are having. In this case, if you have to observe that you what, how many hydrogen is there? Zero hydrogen. Let me just write zero, be like ZERO. Okay, so here you will be having a zero hydrogen, and here we are having one hydrogen. So what is the Marconic rule said? That the negative part of the adding molecule combined with that carbon which one has a lower number of hydrogens. So means from there to there, it's a Marconic of addition, and from there to there it's anti-Marconic of addition. And we discussed this thing already, that in hydroboration we are going to follow anti-Marconic. So in this step we have to use BH3 and THF. That part we discussed I guess two times, the same reaction H2O2 and then NaOH. Okay, and here what we are going to use, that hydroboration part, that AgOC to that part, and then second step is what, NaBH4 that reaction. Okay, so this is how we are going to solve this, Diksha. I hope it's now clear, okay? Still any problem? Then please connect at the end of the class, okay? I hope it's clear now. Okay. So that's it. Now let's continue further. This is all for the question. I hope it is clear now. Now let's discuss about, this is all for the preparation of alcohol. Let me just quickly give you a brief. We discuss about the preparation of alcohol in the last class. We just started with the first preparation from alkane. There we discuss about hydroboration part, oxymercuration, demercuration, or simply addition of acid there. Okay, so this thing we already covered there. And now after that we just discussing about that how to prepare the alcohol from the carbonyl part. We discuss about that some oxidizing agent like KMnO4 in the presence of neutral condition and osmium oxide there. Okay, so there we found following that is a diol, that vicinal diol. Okay, so this part cover. And then from carbonyl part, the grignard reagent, the topic, the very first topic of the today's class. Okay, so that's it. This is all for the alcohol. Now we are going to start with the preparation of phenol. So some may be already familiar, like diazonium salt. Okay, so the it's important, it's a laboratory method, and that haloarine and the cumene one, these two are the industrial synthesis. And the last one is the benzene sulfonic acid there. So let's just start with the preparation number one from diazonium salt. I hope you know now that how to form the diazonium salt. Yes or no? Which reagent we are going to use? I'm going to explain, but still, because we already discussed this thing in the halluarine and halluarine chapter. So this is the first question. How to convert a aniline into the benzene diazonium chloride or BDC? It's our aniline. So which reagent we are going to use? If I want this, benzene diazonium chloride, BDC, okay? Benzene diazonium chloride is the short form. Anyone? Do you know the reagent here? Only NaNO3? Because something is really important here. You know, when we used to form this in our labs, so we have to make sure. Okay, NaNO3 and HCl, okay. But one more is the key point here. Do you know if you have to little bit change the temperature, we end up with a different product. Okay? Yes, the temperature. Temperature is like, it's a really very important point is what? That is a temperature here. Okay? Yes, 0 to 5 degrees Celsius. So how to maintain this? Obviously with the help of ice only. Okay. So about the like reagent, you can use NaNO3 mechanism as well. We're going to follow. No, no, it's not important and very difficult as well. So it's a 0 to 5 degrees Celsius. That's it. Okay, now we're ready with this benzene diazonium chloride. So let's just back again our preparation part here. So the step number one, I hope it's clear now. So benzene diazonium chloride is ready, and now we want to convert into the phenol. You know, a preparation if you want to convert this into the like phenol. So what we are going to do, although it's already written, but just try to answer the question. Water, simply add the water. Okay, simply add the water. This is really important that it's easy to form the phenol with the help of benzene thallium chloride. So just simply add water and we are going to get this. It's simple reaction. Let's see how it's look like. You will be having this benzene diazonium chloride. This is a temperature and this and then warm water and to gas release. What is the key factor? You know that in organic chemistry, how the reaction is proceeding. If let's suppose we are getting side product as a gas. So yes, we are going to follow that reaction. So it's a very easy reaction and even the yield is also very good. Why? Because the reagent, the side product is a gas and HCl as well. Remember the 11th class, there's a so many technique. You know, in lab hardly we get 0 to 0.005 gram something. And if we lose that during the filtration, obviously it's not good for us. So that's why we're avoiding the use of those reaction where we're getting side product which is difficult to remove. The step number one. The second one, that from the dough process. This is a naming reaction. This process we already covered in a haloalkene and haloarine part. Remember that it is very difficult to directly convert a chlorobenzene into the OH there. Why? Because this bond has some partial double bond character because the chlorine has a lone pair there. So there's a three reason. The reason number one, that carbon chlorine bond has some partial double bond character. Okay, that's why it is very difficult to break this bond as compared to the normal RCl bond in aliphatic system. The condition number two, that is a carbon chlorine bond is sp2 hybridized again. So the same thing like sp2 hybridized, so more is the percentage is correct, stronger will be the bond here. Okay, and the third factor is what? That is the phenyl ring is behaving like a crowd group. Okay, you can say phenyl ring hindrance as well. Okay, so three reasons that just because of that we are avoiding the use of direct chlorobenzene for the formation of alcohol. Then every time we are very smart, we be like some reaction when something is not going to happen. Recall I already told you this thing so many times. If it is written reaction is not going to happen, it doesn't mean the reaction is not going to happen. What is the key point? That reaction is not going to happen in normal condition. So wait, why not we can increase the temperature? 623 Kelvin, it's not a very small temperature. It's a very good temperature. Then then it's simple there. So observe this. This is RCl is there, and you are increasing the temperature. If you are using NaOH, we are getting a that phenoxide salt, sodium phenoxide. Okay, and then HCl, and then simply it's replaced, and we're getting NaCl as a side product. Okay, it's simple reaction. Now the again put 2 to 3 to 4 star like every time in the PYQ. If you are solving the PYQ properly, I'm assuming so maybe you already know that it's a really very much important reaction. Okay, that is from cumin, the cum reaction with cumin there. So, like in this case, actually what is happening? This is simple. Can you just tell me what is really happening here? Like the name of the reaction is it substitution reaction or like electrophilic substitution or nucleophilic substitution reaction? This is my question to you. Simple, it's acid there, okay? So it is going to simply attack here. This is like H positive. This is attacking here. Okay, this is not important. I'm just only explaining to you, okay? So that's why what we're getting, it's H is connected here. This is some, wait. That this H is connected here. And this is positive charge, secondary positive charge. Benzene ring simply attack here. And then we end up with this cumin there. Okay, so this is cumin. So we have to start with the cumin. Now the real part starting from here, the mechanism is really important for the cumin preparation. Okay, so you will be having cumin. Let me just explain the mechanism. Wait. This is our cumin. Okay, till then, can you just tell me the IUPAC name for this cumin? Anyone? Cumin is a common name. What is the IUPAC name for this? Yes, very good, Abhishek. It's electrophilic substitution reaction. One methyl ethyl benzene. Okay, you know the rule that if you are having a benzene and there is substitution present in a benzene, so the benzene is behaving like a substituent. I'm repeating the rule that if benzene is connected with the chain, okay, so benzene is being like a substituent. Do the name for this compound that you have to starting the numbering from this because it's our parent chain. It's a main chain. It's a rule. Check it for the 11th class again. Okay, so like how about the name there? Like at second position you will be having phenyl, so it's become 2-phenyl and propane. This is the correct name for this compound, 2-phenyl propane. Okay, it's a rule that if benzene is connected with more than one carbon, so benzene is being like a, yes, very good, Abhishek, as a substituent. Okay then, so first of all, that in this case we are going to follow that we are going to add the oxygen there simply, or you can observe like it's a aerial oxidation. It means an air you're going to oxidize simply, okay? So that what we are getting here, this is a benzene, and this is the thing what we are getting in the very first, okay? That is aerial oxidation. So let me just back again. Let's just see the slide. Okay, so we are getting this that cumin peroxide there. So first of all, O2 there. Till from there to there, the mechanism is not important. Okay, because I will highlight this if mechanism is important for you. So first of all, that aerial oxidation, and what is this? That the same. What was the name? That cumin hydrogen peroxide there. If you have to observe, let me just highlight. It's what? It's a peroxide bond. It's a peroxide bond. Peroxide linkage you can say. Okay, now the second step is the addition of acid there. It's important. Okay, I'm repeating again, it's important step. So from this, let's see how to proceed. So you will be having first of all, and this is important mechanism, so try to draw again with your hand. Okay, yeah, of course you can use anything. Okay, think about it. Actually, what is going to happen? We are having acid. So if let's suppose I am a student, then how to proceed? Okay, No, Lakshmi, if there is a functional group, okay, let's suppose like functional group, if it is connected with the benzene ring, so then benzene become the parent. And if the functional group connected with the side chain, so it's the side chain become the that parent one. The priority order is what? First of all, you to give the priority to the functional group. Then the second priority is given to the such saturation or unsaturation, then substitution, and then the normal number of carbon, Lakshmi, right? So first of all, wait, I will. Oops. So like one, two, three again. So like same that two phenyl and prop propane hydrogen peroxide. Okay, just add hydrogen peroxide at the end of the name. Wait, let me just back again to the slide where we're just discussing about this. Okay, like see, here we write cumene hydroperoxide. So there you just write 2 phenyl and then the complete name propane and then hydroperoxide. Okay, I guess I use hydrogen there. I'm sorry for this. Going to the hydroperoxide. Where's the slide? It's very difficult. Okay, yes, hydroperoxide. Okay, I guess Abhishek, the name is clear for you. Anyway, let's just back to the mechanism. It's important. Okay, so let's try to understand the mechanism. First of all, lone pair, and they're going to attack here. We are getting this is a benzene. O, O, and H, and H. So obviously this is a very good living group now. It is going to leave the reaction there. Okay, it is going to leave the reaction. Then what we are end up there? That we are end up with this. This is going to leave, and that simply O negative and this. This is the first step we are end up. Okay. So in this case, like although like in this case the resonance is also there, that negative charge simply transfer here. Okay, resonance is also possible, but like we can't go with that. So it's enough. It's okay. Okay, that's it. Now, next step is just to understand, just for understanding only. Okay, so observe actually what is going to happen. This benzene ring, okay, just try to understand how the bond break. This is how the bond break, and this is connecting with this oxygen. So what we're getting, that oxygen connected with the benzene ring now, and this is how the bond break. Let me just explain one more time actually how the shuffling is there. Just try to understand this part only. This is oxygen. Okay, so you can say this bond simply combine with this oxygen like this, and this bond break. Okay, this bond break, simply this bond break. So what we are getting simply that this is connected with oxygen. Okay, and it's a positive charge generated here. Okay, just try to understand what is really it is. So this bond simply shift here. So basically now we are getting this. That's it. Now the second step is what? Again, the water came to the picture, okay? You can simply stabilize the positive charges like lone pair maybe attack here. So let me just draw the resonance as well. Double bond, okay, like this. And there is a positive charge. So these two are the resonating structures of one another. Okay, so after this, let's move to the next slide. So now I will be having this. Now again, water come. So water attack here. This bond open up. O single bond, and this OH connected here like this. Positive charge. Oxygen has a lone pair. This is attacking here. OH and OH. Now the next step. This okay. This bond like this lone pair like this. And now we are getting phenol plus. This is how it's look like. And then H positive is going to leave simply. Okay, let me just erase this and see, this is important. This is really very important. This is the only reaction where the side product is really important, that acetone. It's a one of the famous reaction that in cumene synthesis along with the phenol we are end up with, that is a side product is this. Okay. Oh, isopropyl. Just wait, Lakshmi. I will explain. Just wait for a second. Okay. So is the mechanism clear? First of all, just listen my point. I know mechanism little bit difficult for you. Okay, just try to yes, isopropyl can be a IUPAC name as well, but like if you to compare between isopropyl part and that part, so the choice was that the 2-methyl one is the good one. Okay, so isopropyl is again, like it's not a common name, it's still a IUPAC name, but like you can select between them. So what we're discussing is this is a water simply, and water connected in. This is, look at how the reaction is going on. Okay. Any problem with the mechanism? Shall I repeat one more time? Okay. So let's just discuss the naming part as well, right? So if you have to go with the cumene, I already told you the trick how to check it for ISO, that you are going to check it for the Y. Remember? So it's a Y there. So it's what? It's ISO first of all. ISO. Then how many carbon? One carbon, two carbon. It's isopropyl. Okay. And what is it? It's our benzene. So it's isopropyl benzene. So yes, this name, and listen my point. That one word we just discussed, that is a 2-methyl, sorry, 2-phenyl. That is 2-phenyl and propane, right? So both are like expected by the IUPAC. Okay, both are expected, but important is what? If you are going to select, let's suppose this is also given an option, this is also given, so you have to go with this is the only answer. Okay, we discussed this rule in 11th class if you remember, right? Is this point clear now, Lakshmi? That actually what is cumene and actually what is isopropyl benzene and actually what is this? Okay, so that's why NCERT is not easy to understand, right, Lakshmi? So that's it. This is all for the cumene reaction. Let me just back again toward the preparation part here. So cumin, cumin, cumin. I hope it is done now. Okay. Yes, done. Now let's see the next preparation, the third preparation, that preparation with the help of benzene sulfonic acid. Okay, I hope you know the meaning of like benzene sulfonic acid. This is SO3H. It's a benzene sulfonic acid. How to form this again? What is it? It's a uh, electrophilic substitution reaction of the 11th class. Electrophilic substitution reaction. And here we are using a oleum there. Or sometime it can be fuming H2SO4 as well. Okay. Or like sometime it can be H2SO4. Wait. Let me just change the color. Or maybe it can be H2SO4 plus SO3. All three are okay. Now, this is simple. That is a sulfonation. And if you're using NH is there, so listen, that with SOH we are going to follow that ipso substitution. You know the meaning of sine and ipso or not? You know sine or ipso? Please confirm yes or no. If you don't know, I will explain. Let me just write what I want to ask really. I'm asking ipso and sign. You are familiar with these words? No? Okay, let me just explain. Just try to understand. For example, if let's suppose this is a OH group, okay? And we are going like follow the nitration part, okay? That HNO3 and then H2SO41, and in this case we're going to use the dilute HNO3 there. Okay, so as we know, it's a plus M group simply, and it's a ortho and para-directing group, right? Now, so it means that nitration may be at this position, okay, or maybe at this position. Okay, so what is it? It's a sign. Sign simply. That what is the meaning of this word sign? That if let's suppose the substituent connect here, so with respect to that substituent, the next carbon. Look at this. This carbon with this carbon. So this is a sign kind of substitution. But let's suppose in the same reaction, I'm using this. Wait, and this is SO3H. Let me just use bromine water. Okay, so it's a rule. If you're using a bromine water, so bromine water, like this is a OH, it's again a plus M group. It is a ortho and para-directing simply, right? So what is the key point here? If it is a ortho and para-directing, so again this is OH, SO3H is connected here, and then bromine connected here, and bromine simply connected here. This what we are expecting. What we are expecting, but actually SO3H is a ipso kind of group. In the mechanism part, yes, bromine has a tendency to displace this group as well. Like if you have to go with the mechanism, let me just write the mechanism part as well, how to follow that. SO3H, this is how it's look like. So observe this oxygen has a lone pair, this simply transfer here, and then this bond, let just create a gap. Wait, this is moving here, okay, and this bond is moving here, and this SO3 is going to release. Okay, so what we are getting simply that we are getting double double, and this is a negative charge. Okay, and this is a OH group, and this is a bromine, and this is a bromine, and this SHSO3 group is simply releasing. Okay, now bromine, okay, there's an like negative charge, I'm sorry, double bond and positive, and then bromine simply attack here, positively one, this here, this bond like this, everything is back normal. So what is the key point here? That SO3 is also replaced by the bromine. So let me just highlight the position, which, and it is a really famous reaction if you don't know, is SO3 group, and this is a bromine group. Look at this on the same carbon, on the same position, that this is replaced by some other group. So it's a ipso. Okay, I used to remember like ipso means usi par, like in Hindi. I don't know you know Hindi or not. Ipso means on the same carbon. Yes. Okay, like on a same carbon, that SO3 group is replaced. So with respect to the SO3H group, the bromine addition is a ipso addition. But in a sine one, that other than that's different, same carbon. Okay, like in the previous one we just discussed, let me just again repeating. Look at this. If you have to observe, like this is the main group here, and with respect to this. Okay, so be noted that actually what is happening there, SO3H most of the time follow the ipso, that two group in the organic chemistry. One is this, and one is COH group as well. Two group. One is SO3H and one is COH group. Two group going to follow the ipso kind of substitution. Be noted. Make this point as a note. Okay, I hope it is clear now. So anyway, let me just explain again the reaction what we are discussing. So it means this SO3H group simply replaced by the OH group here. Okay, so that's it. This is all for the preparation. Done with the preparation part. In the next class, we're going to start with the physical property and chemical property. This is all from my side. Okay. Thank you so much, Abhishek. This is just because of you only, right? because I never ever have idea like I have to make a some kind of channel. But okay. Any problem? Still, please, anyone? W. What is the meaning of W, Mini? I don't know about W. This is a kind of like what? When? Oh, yeah, it's some century, right? Yes, please. Any problem? First of all, of course, this is for everyone. You are the winner. Maybe. Okay, then revise the thing. Okay, Dashika or everyone, and I'm going to take the next class. Thank you so much. From Monday, okay? Because I guess tomorrow Durga Ashtami and then the Dasara, okay? I guess you are not going to join, and even also I'm busy there, okay? So let's arrange the next class from Monday, and from Monday, okay, and from Monday that there is a no holiday for Wednesday, okay? I'm repeating this. And if let's suppose that we are not able to manage the time, so maybe I will take two classes per day. Okay, so be ready for this, everyone. Okay, that's it. This is all from my side. So thank you so much for joining the class. Thank you so much. And then have a nice day. Okay, thank you. Yes, please. Now you can leave if you are not having any problem. Of course, but I'm not taking because on Sunday everyone is busy. I ask all time. Okay, thank you so much, Meeda, and thank you so much, everyone. And first, and again that like happy Durga Ashtami and then the Sarah and of course Ram Navami as well. So then, okay, enjoy your festival now. Okay, and please be noted, okay? Just it's not like okay, the festival is going on, so please revise the thing as well. Okay, revise the thing properly. It's really very much important, okay? Thank you, Many. Thank you so much, everyone. Thank you so much for your wishes. Thank you, then. Let's end finally, okay? I guess it's enough.